All right, let's jump right in. Today we're looking at a piece of hardware with maybe one of the most technical names I've seen in a while.
That's a bit of a mouthful.
It is. The Kramer MC3-2RI 4K60 HDBT 2UKIN card with analog audio. But, if you strip away all that, we're not just looking at a circuit board here.
No, not at all.
It feels more like we're looking at the nervous system of a big professional AV setup.
That's the perfect way to frame it. I mean, the whole mission of this deep dive is really to figure out how you solve this fundamental problem, moving massive amounts of data, video, audio control signals over long distances.
Without it all just falling apart.
Exactly. And this card, it's a 2-port input device. It slides into a bigger matrix switcher, and it uses HD-based technology to basically beat the laws of physics when it comes to distance versus quality.
Okay, so that must be where the 4K60 part of the name comes in.
Yeah.
Because we're all used to 4K screens, but pushing that signal is a heavy lift.
It's a very heavy lift, 60 frames a second HDR.
Yeah. If you try to push that down a long copper cable, you're going to get artifacts, signal drop. It's just not going to look good.
So how is this card cheating physics?
It's using a really clever low-level video compression that's designed to be visually lossless.
Meaning my eye can't tell the difference.
You can't tell. It's handling full 4K at 60 Hertz with 4.4.4 chroma subsampling. And that 4.4.4 part is key. It means no color data is being thrown out. What you see at the end is identical to the source.
And we're not talking about the short HDMI cable you have behind your TV.
Oh, no. We're talking infrastructure. This card can push that heavy 4K signal up to 100 meters.
100 meters, that's 330 feet.
Right. And if you drop down to 1080p, you can go up to 180 meters. That's nearly 600 feet.
That's impressive. I also saw something in the specs about intelligent compression handling. So it's not just, blindly squashing the signal.
No, it's actually negotiating.
Yeah.
The card is smart enough to detect what the receiver on the other end can handle. If the connected device doesn't need compression, it just turns it off.
Oh, interesting. But if it does, it adapts. It avoids that classic headache where a new 4K source just refuses to talk to an older display. It kind of future-proofs the whole installation.
Okay, so the video pipeline is solid. But looking at the ports on this thing, it's like a Swiss Army knife. It's not just video. I'm seeing Ethernet, RS-232, IR ports. Why is a video card handling IT networking?
Because in a commercial install, think of a boardroom, a lecture hall. You rarely just send video. You have to control the room.
You mean turning the projector on, lowering a screen, that kind of thing?
Exactly that. This card acts as a bridge. It embeds those control signals right alongside the video. So through that single HD basic cable, you're getting Ethernet, serial control, and infrared.
So the IT team can remotely manage the room without having to run a bunch of separate control cables.
Precisely. It simplifies the physical wiring so much. And on top of that, it supports PoE power over Ethernet. The Matrix can actually send power down the line to power the receiver at the far end.
That's huge for installers. No more hunting for a power outlet in the ceiling.
Yeah.
Okay, so that leaves the last part of that long name, analog audio. In a 4K digital world, that seems very specific.
It's all about flexibility. It's a feature called intelligent forward audio routing. Usually audio is just trapped inside the HDMI stream. This card lets you de-embed it.
So you could send the video to a projector, but send the audio to a separate high-end sound system.
You got it. You can strip the audio out right there. Or you can do the reverse. If you have a presenter with a microphone, you can inject that audio into the stream.
Override the original HDMI audio.
Right. It even handles ARC, the audio return channel. So audio from, say, a smart TV app can travel backwards up the cable to the main room speakers.
It really is doing everything but making the coffee. The takeaway here is that this isn't a passive connector. It's an active traffic manager for video, power, control, and audio.
It makes sure the infrastructure in the rack doesn't become the bottleneck. We always focus on the fancy screens, but this is the gear that actually makes the pixels appear.
It keeps the traffic flowing, which leaves us with a final thought to mull over. As we push towards 8K and beyond, that data pipe has to get even wider. At what point does visually lossless compression stop being enough and we have to reinvent the cable itself?
That is the big question, isn't it?
Something to think about next time you plug anything in. Thanks for listening to this deep dive.